Hello everybody, my name is Lars Griem. I'm part of the research group that is currently developing the research data infrastructure Kadi4Mat, and today I would like to present to you a use case that I've implemented with which we can identify and visualize structured property linkages in material databases using machine learning algorithms. The first concept that you have to be familiar with in order to understand today's presentation are so-called structured property linkages. We as material scientists, we're usually interested in how the material and its components, as well as its microstructural features, affect the macroscopic properties. And the link between the microstructure and its effective properties, so the macroscopic scale, they are defined using so-called structured property linkages. And in order to visualize these structured property linkages, we can use so-called materials maps. These material maps are shown on the right-hand side here on the slide. And they just visualize these structured property linkages using a comprehensive 2D scheme. And this material maps helps the user to understand how a certain component influences the macroscopic property of a certain material, so they can tune these materials to their certain needs. As I already said, today's goal is to retrieve these structured property linkages automatically from databases using machine learning algorithms. And these databases, as well as these machine learning algorithms, are all implemented in Kadi4Mat. Kadi4Mat is the Karlsruhe data infrastructure for material science, and it consists of many different modules, which in sum form our ecosystem, Kadi4Mat. The two modules that we're going to look at today are KadiWeb as well as KadiStudio. And for those of you who are not familiar with Kadi4Mat or have never seen it, I will just give you a brief introduction to both of these modules so that everybody is on the same page today. KadiWeb is the website that you might have already seen, which you are redirected to when you log into Kadi4Mat. And on this website, so KadiWeb, we can upload and structure our research data using metadata schemes. On top of these metadata schemes, we also have the possibility to link relations and in this way incorporate ontologies into our database. On the other hand, the other module that we're going to use today is KadiStudio. KadiStudio allows us to model research processes in an automatable and reproducible fashion. That means that we do not only have the possibility to upload our research data in Kadi4Mat, but we can also model the underlying research processes in order to make these research data reproducible and understandable. And as both of these components are part of Kadi4Mat, they have the possibility to communicate with each other. That means within KadiStudio we can access all of the data that we have in KadiWeb, download it, then investigate it using machine learning algorithms, and finally upload our results back to KadiWeb. So let's have a closer look at KadiWeb. As I already said, in KadiWeb we are just uploading our data and we're structuring it using metadata. For this we're always using so-called records. These records, they are the basic containers of Kadi4Mat, and they usually consist of our research data that we would like to upload, as well as corresponding metadata. These metadata schemes, they can be freely defined by the user, so it's up to the user how he wants to define the metadata, and he can select certain schemes and imprint them into his records. For us, at this point, it's very important that we use uniform metadata schemes because we are going to extract all of the information later on from these metadata with machine learning. So it is important that every record has the same metadata keys at least. On top of the metadata, we also have the possibility to link records to each other in order to visualize some relations as well as ontologies in Kadi4Mat. So this is everything to KadiWeb and to KadiStudio. As I already mentioned, KadiStudio is the workflow editor of Kadi4Mat, which allows us to model research processes. Within Kadi4Mat, we have the possibility to access the API, so the application programming interface of Kadi4Mat, to retrieve data and to communicate with KadiWeb. For this, we have the Kadi API tool nodes available in KadiStudio that just make use of this API of Kadi4Mat. Within KadiStudio, we also have the possibility to use machine learning algorithms, so we can not only retrieve data from KadiWeb, but we can also investigate these data sets or this data using machine learning algorithms with specific nodes that we have incorporated in KadiStudio. So now that you know the tools that we have at hand, let's have a closer look at the use case that we're going to look at. So as I already mentioned, we have a database of materials that we would like to investigate automatically using machine learning. So the next interesting part would be the database itself. This database was created by myself in this use case. So what I did is I created many different records for many different materials that we are looking at in our project. And these, these microstructures or these structures that we're looking at always hold different properties. So we started by generating different materials, creating records, and then we uploaded the properties of these materials as well. For this we used different records, so each property is split up into a single record, and we can differentiate them between structural and effective properties. So this means that within the structural properties we have all of the information about the microstructure and as the microstructural composition of our material that we're looking at. And in the effective properties, so in the effective records, effective metadata, we have all of the macroscopic properties. So in case of batteries, this might be the conductivity, for example. Or in our case, for example, this can also be mechanical properties. So this is the idea, how I wanted it to be structured, and how it looks like in Kadi4Mat itself is something like this. So for each of these properties, we have its own record, and they always contain the measured properties. So depending on which property we're looking at, we have either the effective properties, which are stored within the extra metadata, or we have the structural properties that are stored within the metadata. Now here again, it is very important that we make use of the same metadata scheme. So we always have the same keys in our structural properties as well as in the effective properties, so that we can extract information using machine learning. So this is the structure that I chose, and with this structure I generated a large database that I can investigate in the next step. So this is just an overview of the ontology that we have imprinted on our database. So each of these dots represents a structure with its corresponding metadata. And in the next step, we would like to use this database in order to retrieve our structure property linkages. So what we want to do is we want to extract the database to KadiStudio, use machine learning, and then generate this map that you can see on the right-hand side. So the first step that we have to do, so the prerequisites for our machine learning approach to be working, is that we have to, first of all, retrieve the data from Kadi4Mat and make it available in KadiStudio. In the next step, we can iteratively train neural networks that get more precise and more accurate over training. And last but not least, we can start to generate the material maps that just summarizes the information that we have retrieved from the database in an easy image. So the first step that I would like to present to you now is the data acquisition or the data retrieval from Kadi4Mat. As I mentioned, everything that I did is documented and made available in generic workflows. And these workflows is what we're going to look at now. So this is KadiStudio on the right hand side. This is a screenshot, and if we want to retrieve the data, we just have to press on play, and then the workflow is executed. And what happens in the background is that Kadi4Mat, so we have, first of all, we have to select a few scripts from Kadi4Mat which are available on Kadi4Mat for everyone who wants to use them. And then we have to select whether we want to use the metadata from a file that we might have available, or if we want to extract them from Kadi4Mat. Here we decided to extract them from Kadi4Mat, and we get redirected to the next window where we again have to select a script, and we have to define the collection of all of the records in Kadi4Mat that we would like to retrieve the data from. What happens now in the background is, with all of the information that we provided to KadiStudio, KadiStudio starts to communicate with KadiWeb. And it asks for all of the information, all of the records that are contained in this specific collection that I just asked for. So KadiStudio asks Kadi4Mat for the information, and the information gets propagated back to KadiStudio. KadiStudio will now analyze all of these metadata that we have available and present us in this form, as you can see here. And then we can select all of the input data that we would like to use from the metadata for our machine learning approach. In this case, we're just selecting all of the input data, and the output are just the effective properties that we would like to look at. Once we have selected all of the information that we would like to retrieve from this database, they are being put into a TF record, so in a machine learning appropriate file, and stored in there. And now they are made available for further use in our machine learning approach. So what we just did is that we got our database with all of the information, so effective properties and structural properties and macroscopic composition of our material, and we turned them automatically and interactively by selecting all of the input and output features into TF records that can be used for machine learning. So now the data acquisition is completed and we can start to train a neural network. Here again we have a machine learning approach and a workflow available that is generic and can be used by anyone who wants to do so. And again, when we start on play, we have the possibility to define our training schedule as well as our model. First of all, we have to define the model and we have to specify how many layers we would like to use within our network. In our case, we're just using a fully connected network, so this is why we're just having to define the number of dense layers here. Then again, we have to select a Python script that is available on Kadi4Mat. So this is also available in for everyone who wants to use it. We're downloading it and for further use now. Then the TF records. These are the data that we just retrieved and made available in this TF record format. We're just selecting them locally from the file that we've just created. I've pre-selected this file. You can just select it, and now everything required is selected. And now we also have the possibility to enable explainable AI. This is feasible, or this is important at this point, because we just extracted all of the information that we have on Kadi4Mat regarding these materials, but we do not know which materials or which aspects of this material are important for our structural property. So what it does, when we click on use explainable AI, it will not only train a network that can predict our effective properties from our structural properties, but it will also go on and analyze the network to see which input information influenced our prediction in which way. So first of all, after we selected all of this, we can define our training schedule in our model in a bit more detail. So we have the possibility to select the units, so how many neurons we are going to use. We can use the activation function, and we're just going to set the units in the second dense layer to 64. The rest is okay, and we can click on to continue. And now in the background, everything is live. So in the background now the training starts. And the network is being trained with our fully connected network that just takes these 6 input values that we selected in the beginning in the data conversion to our effective properties. And if we go onto log, we can see how the training progresses. So first of all, it has to load some libraries, but now it starts our training. And we get a short overview of the network that we've defined. So you can see we have the 6 input values, then our network with 32, 64, and again 32 units, and our effective properties that we would like to predict. Now the training starts, and what it basically does is we're taking a fully connected network, so with three dense layers, they are connected to each other, and we're training this network just to predict our effective properties, so the macroscopic properties from our structural components. So this can already be considered to be the first step of identifying structural property linkages. The problem here is, however, that we're using all of the structural information that we have about our material in order to predict these properties. But what we want in the end is that we would just want a few important structural components that influence our effective properties. So this is why, after we have finally trained this network, as I mentioned, we're going to use explainable AI techniques in order to investigate the influence of all of our input values onto the prediction. So now the network is almost done training. It takes a few more seconds, and then we will be presented with the analysis of our final network, so that we can then go on and create new data sets. So now the network is done, and we can see here in this summary that component 1, which was the porosity of our material, contributes 49% of the information. So this seems to be a very important influence in our effective property, as well as component 5, which contributes with 23%. So this is the information that we have now, is that we know which structural components influence our effective properties the most, at least from machine learning side of point of view. So what we're going to do now is that we're going to do an iterative training. So we are going to create a new data set that only contains the components that are the most important for our prediction. So component 1 and component 5. For this, again, we're going to use our generation workflow. It's the same as in the beginning. So we're going to select again the script that we would like to use. We're going to select that we would like to extract all of the metadata for our training from Kadi4Mat, so from our database automatically. Then we're going to select all of the necessary files, as well as the identifier. So it's the same procedure as we saw earlier on. And now we are being presented with the input again. So KadiStudio again retrieved all of the information from Kadi4Mat, and we now have the possibility to select whichever feature we want to investigate in our neural network. As we know from the previous training, component 1 and component 5 are the most influential. So we're going to select the input features 1 and 5, which are the porosity as well as the mean pore size in this case. And the effective properties, they are being left alone. So we're just going to predict the same effective properties as in the previous training. So now that we have created this new dataset that only contains the most important features, we can go on and train a new neural network just on these two components that predict the macroscopic properties. To do so, again, we're using the same workflow. So the training workflow again, we're defining our network. We're selecting all of the scripts that we need that are available on Kadi4Mat. And we're selecting the network that we would like to use. In order to make it a bit more comparable to the first of the previous training, we're just going to use the same setup. So the same training schedule with the same number of epochs and the same network. So 32, 64 and 32 units in our dense layers respectively. Once we have done so, we are going to train our network the same way as we did before. We can just fast forward and then see that we have successfully trained our network in which component 1 and component 2 predict our effective properties. So now what we have achieved is that we have extracted information from our database using machine learning in KadiStudio, and we have trained a model that is able to predict the effective properties of a material just from two structural properties of this material. So now we have two parameters that influence the effective property, and if we have just two influencing factors influencing a parameter, we can visualize this in a so-called materials map. And the generation of this materials map is created in this last workflow. So it is again available on Kadi4Mat. You can use it, and how it works is again shown here. So we just start the workflow, then we do have to select some files from Kadi4Mat. It's the same as in the other workflows. We just select the script. We can either select it directly or search for it if it's not available yet. Then we're going to select the network, so the model that we trained in the training process. And then we're going to define an interval that is being put into our network for the first parameter as well as the second parameter. This is important because our network was just trained on a certain interval, so we have to make this interval also the input values for our neural network. Otherwise, it will probably not work that well. So now in the background, we're using our neural network. We're feeding it this interval that we defined, and it will generate us predictions for each of these points. And this will generate us a data set, which we can then visualize using, in this case, voice. So we're just selecting the results of this workflow, and we are turning it into a 2D data set. This is fairly easy. So this is how it's created, and then we can visualize this map automatically, and we can directly see how these components that we have identified using machine learning as well as explainable AI affect our effective properties, so the macroscopic properties, and we have everything visualized in this comprehensible map. So this is the last step of the workflows that I created, or for the use case, and as a summary, we can say that I presented to you a use case or an implementation of workflows in Kadi4Mat with which we can analyze databases in Kadi4Mat with machine learning. On top of that, we can not only analyze them using machine learning, but we can also identify the most interesting or the most influential factors for effective properties using explainable AI, and then in turn automatically generate our materials map using Kadi4Mat and KadiStudio. As a last note, all of these workflows are going to be made publicly available on Kadi4Mat once they have been published. Thank you very much for your attention.